Alright, ladies and gents, on today's episode of Swapology, we are going back to the Project Silver Bullet FX. Now, what you may remember from the introduction video is that this FX is currently lowered on BC Racing coilovers, and it's essentially set as low as it can go, and it's a little deceiving in pictures because the maximum lowering on this vehicle is actually like 3.5, 4 inches lower than stock. It doesn't look like that, but it is that much because the tire diameter that we're running is also smaller than stock. So to get that wheel gap as small as possible, we really had to drop the suspension a lot. And as a result of that, we ended up with a lot of negative camber in the rear and the front. The front, we were able to dial a lot of that out because the way the coilovers are set up from BC, they take care of it. But in the rear, the suspension adjustment was maxed out, and we still had 3.5 degrees of negative camber, which is way too much to get really good traction at the track. So what I actually ended up doing was cutting, sectioning, and re-welding the factory rear control arms for both camber and toe. The rear camber arm was shortened a bit, the rear toe arm was shortened a bit as well. And what that was able to do for us is get our factory adjustments back close to spec. We were actually able to get the rear camber to 0 degrees if we wanted. We actually set it to 0.5 degrees negative, but we could have gone straight to 0 if we wanted, and the toe was right within factory spec as well. And what that'll do is allow the FX to hook up better at the track, because with the amount of power it's making, that's a serious downside with that much camber, is trying to get this thing to hook up at the track. So now that the camber is corrected, the problem we ran into is actually the tires rubbing on the lips within the rear fender well. And the FX has some pretty aggressively large lips in the rear fender. They're like over an inch wide, which I'm sure you saw at the beginning part of this video. So what we were doing here was actually cutting the plastic trim in the offending area in the wheel well to get some more clearance to reveal the metal trim that's behind it. And then here we're attempting to roll the metal trim. Part of the problem is the wheel well is so big, the fender rolling tool itself isn't long enough to reach the fender well. And the other problem is that the fender well material itself is so heavy duty that honestly the fender roller wasn't even having any effect pushing on it. So what I just did is actually grab the sledgehammer to bend it up. I wasn't really concerned about basically beating up the body on this thing too much, because it's so whooped already. I mean, this thing has a bullet hole in it, mismatched quarter panels, a bunch of dings and dents. And secondly, with the black plastic that covers the outside, if I went a little too far, you wouldn't even see it because it's actually all being covered by that black plastic trim. So the sledgehammer was the easiest way to get it knocked out of the way. There's one spot in the top center, this spot right here that I'm hitting a little more on the wheel wells, that is actually like 5 layers thick, and it's because it's where the rear door jamb is, so there's more reinforcement in there. But I was still able to get it knocked in quite a bit all the way around, and this was enough of a modification to get us plenty of clearance, so these tires don't rub anymore on any level of bump impact at all, which is really nice. 295 tires are pretty expensive to replace, so I don't want to just keep shredding up tires. And I'm confident that once we put the drag radials back on this thing, they won't rub on a hard launch either. Once the rear suspension was done, we were moving on to installing an overdrive crank pulley. But here I'm giving a little underbelly shot of the FX. And once we get to the rear, you'll actually be able to see the rear camber arms where they were sectioned and shortened and reinforced. The toe arms, or the spring buckets, it's actually harder to see because I was actually able to plug weld in the holes where they bolted to the spindles, and then grind smooth and re-drill that hole about a ½ inch further in. So it's almost invisible to the naked eye just looking at the truck that those arms have been modified at all. But here we've got the overdrive crank pulley that's being installed. This is a pretty nice piece from PowerBond, and they're fairly inexpensive. It's nice because they're SFI spec. It's also nice because they're 8 rib as opposed to 6 rib. Here I'll give you guys a little view of the part number itself. If you were ever interested in ordering one, you can see the end of the part number is SC10 because it's for a supercharger and it's 10% overdrive. It's keyed from the factory, and you could probably see from that original shot of the factory crank pulley that's on there that we did actually drill and pin the stock pulley. But here we're going to go ahead and pull off the AC belt and get the factory damper pulled off. And unfortunately, we're going to have to re-drill the crankshaft to key it again for the new blower pulley. The original blower pulley, it's going to be impossible to push on the new pulley in the same orientation of where the old pulley was to try to get the pins into those key grooves. And it would also destroy the drill bit if I tried to align the drill fixture with the old holes in the crank. So instead, we're just drilling new holes. It's not really going to hurt anything any more than keying it in the first place would. So here I'm actually using a leftover Magnuson tool from another supercharged build that we did, and a 90-degree drill, and just using a 1/4-inch drill bit to drill some alignment holes to key the damper pulley to the crankshaft. And you can see the new holes that are drilled there, and using a vacuum here to get any metal chips or residue out that were in the way. And then essentially the new pulley hole, or the new keys, they're just a little 1/2-inch long, 1/4-inch diameter dowels press in. I use some RTV to help hold them in place and seal everything up, and then putting in a used OEM pulley bolt just to set the initial torque. So if you're running OEM crank damper bolts, they actually need to be torqued first with a used bolt to something like 220, 240 foot-pounds of torque. Don't quote me on that, but it's quite a bit. And what you do there is just torque the pulley bolt down to set the press fit preload between the damper and the crankshaft itself. And then here, that's what we did, is we tightened it down, and then we're loosening it up, and then you actually throw away the bolt because the bolts are torqued to yield. You can't reuse the factory bolt for the final install, but then a new factory bolt is installed. They're fairly inexpensive. It only gets torqued to like 37 foot-pounds of torque, something pretty low, and then it's an angle measurement. And what I do for the angle measurement is actually draw a line with a paint pen on the pulley bolt itself and on the damper at 140 degrees, and then just turn the bolt until the lines align with each other. I've done it so many times, I eyeball it. I'll be honest with you, if I'm within 5 degrees, I'm okay with that. I am sure there's plenty of people out there that would disagree with that method, but I've never had a failure. And I'm trying to get a protractor up in there to actually do a measurement. It's pretty difficult with the space between the radiator and the crank pulley. I do use a protractor if I'm doing this on an engine stand because it's so easy to make the measurement that way. But again, I've got a pretty good eye for this kind of stuff, and that's the way we did it here on the FX in an effort to save time. This overdrive pulley only overdrives the 6 rib, so the same AC belt that we pulled off can go right back on to drive the air conditioning. It does not overdrive the air conditioning at all. Again, it is just the main accessory drive. So yes, this is going to overdrive the alternator and overdrive the power steering pump, but again, for the type of use that this vehicle sees, it's really just a street car that cruises and then occasionally sees high RPM at the track. It is not that big of a deal to me to overdrive those parts. And I like the fact that I now have an 8-rib crank pulley and an 8-rib blower pulley. I can start doing some research on figuring out an 8-rib alternator pulley and power steering pulley that will fit the Nissan accessories to eventually convert the whole system to 8-rib drive. After that was done, we're going to the high-speed mode here. We're actually going to be pulling the transmission out of the FX to install a high-stall torque converter between the transmission and the engine. And basically, I spoke in a previous video, I think the introduction video about the FX, how the 6L90 transmission that's installed in it is actually using the factory torque converter from that application, and that transmission came out of a 2013 Chevy Express van. And truck and van applications usually have pretty darn tight converters because of the type of use that those vehicles see. And when trying to launch this thing at the track with a converter that tight, it was actually very difficult. So here Jay is actually pulling the transmission out of the vehicle so we can install a 3200 RPM stall converter from FTI. It's a triple disc lockup unit. It's a really nice part. Should work out really well for making this thing a whole heck of a lot easier to launch at the track. And getting the transmission out of one of these vehicles, it can be done from below. There's no reason to pull the motor or anything else, even though we do set the engine pretty far back. So I'm skipping a little forward, but Jay had basically dropped the trans out and reinstalled it with the new converter, and then came and got me out of the back shop, and basically we checked the clearance between the converter and the flex plate. And you need to have a specific amount of clearance between the converter and the flex plate, and we were too tight in this installation. We needed to open up the clearance by almost a full 1/8 of an inch. A little extra wasn't going to hurt anything. But that's really important to measure whenever you're installing these things, especially a high horsepower performance application. You need to have the correct converter to flex plate clearance, because if you don't, you end up having the converter too close to the pump on the transmission itself, And on a hard launch, or when you're foot braking one of these things, putting a lot of power through it, the converter actually grows from all the pressure inside. And if you don't have enough clearance between the converter and the transmission pump itself, when the converter balloons, it will drive the converter pump drive further into the pump, which can damage the pump on the trans, and it will also put an unusually high amount of pressure on your thrust bearings in the motor, and it can wipe out the bearings in the motor as well. So we had to drop the trans back out to put a spacer between the trans and the motor, and not a big deal, but what ended up being a real problem was we actually had not enough dowels sticking out of the engine to align both the spacer and the transmission itself. So we had to pull the dowels out of the motor to get more clearance. And if you've ever tried to pull a steel dowel out of an iron block that's been there for, I don't know, 7 or 8 years like these have, that's not exactly an easy task to do. So what we ended up doing was trying to knock them out from the backside. Those dowel holes are open on the backside, but then you've got the headers and the starter and steering shaft and a bunch of other stuff in the way, so you can't get a good swing with the hammer. What I ended up doing was drilling and tapping the dowels to like an M8 drill size, and then using a socket and an M8 bolt tightened through the socket. The socket acted as like a press to pull those dowels out. It worked, but it added a bunch of time to this install. I'm talking like 3 or 4 hours more time worth of work. I didn't film all of it, and be thankful because it was really boring to watch, but it worked. We got the dowels pulled out. One got destroyed, so we replaced it. The other one I was able to just pull out enough to make the alignment correct, and then Jay was able to get all this stuff finally bolted back together. So he got the transmission reinstalled, as you can see here. He's working on getting trans cooler lines hooked back up, getting the shift linkage hooked back up, and a bunch of other little odds and ends. There's some braces and brackets that were removed that have to get reinstalled. He had to then tighten down the torque converter to flex plate bolts. Another little tip here, don't install the first bolt and tighten it down all the way. Just get it started and get it tightened down enough so that it's the head of it's against the flex plate, but that it didn't actually suck the converter in hard against the flex plate yet. And then rotate the crankshaft to install the rest of the bolts, and don't tighten anything down until all 3 bolts are at least fully started, because if you tighten the first bolt down all the way and then rotate the motor, there's enough tolerance in those bolt holes that you might not even be able to get the next bolt started, and then you're rotating back to loosen up the previous bolt. It's kind of a nightmare. So get them all started and snug down a little bit, but not tight, and then once all 3 are started, then you can fully tighten them. But then you can see here Jay's got the drive shaft reinstalled now. The drive shaft is super beefy on the FX. It's like 5-inch diameter aluminum with 1410 U-joints. Definitely not a part I am worried about ever breaking on this truck at the power level that we're at, even with how heavy it is. And then he's actually putting never sees onto the slip joints on the headers, and we do that on every slip joint exhaust system. Basically, if you ever want to get it apart someday, putting some never sees or anti-sees on the slip joints will make life a whole heck of a lot easier if you decide to start taking these things apart someday. And then it also makes it easier to install because you're lubricating these slip joints, and then you just tighten the clamps down, and here he's got the rest of the exhaust installed, and that's pretty much wrapping up this build. Again, thank you so much for tuning in to watch these videos. Please like, subscribe, share these with your friends, smash that notification icon. We're really trying to build our YouTube followers so that we can bring more and more of this content to you guys and show you more and more of the unique builds that we have here going on at LOJ Conversions. So again, thanks again for tuning in, and we will talk to you soon. All right, take care.